Hello, welcome to the exam review or the exam solutions for the Grade 11 2025 February midterm. Enjoy. I'm just going to skip straight into it. Apologies. Okay, write down the equation of the vertical asymptote of f of x. Vertical asymptotes happen when x cannot be a particular value. This normally happens if I'm going to get anything over 0 or the square root of something negative. If either of these things, this is not allowed in maths. This one, don't worry. But for now, consider both of them not allowed. Therefore, I need to find what x can't be. There's a reason this is 1 mark. It's because it's given to me. X can't be 0. So if x can't be 0, then my vertical asymptote is where x is 0, because where x is 0 is a point where this will never ever meet. So 16 over x, add x squared over 8. If I plot this, where x is 0, this middle bit, it never ever reaches there. If I draw on a vertical line where x is 0, never mind, it will never ever reach that line. Okay. B, find the derivative of f. Before we can do that, we need to make it a polynomial. We're making this a polynomial by remembering that anything over x to the power of n is a x to the negative n. So if I have 16 over x and there's secretly a 1 there, that will be 16 x to the negative 1. Now I can differentiate this. When I differentiate, I get negative 16 x to the power of negative 2, add 2 over 8 x. Part C, I want to find an interval for which this is an increasing function. I can plot this graph, negative 16x to the power of negative 2, add 1 over 4, x, graph, there we go. We're going to make the zoom normal, just to make it easier to see. There we go. So this, the gradient function, is positive. Bit of a rewind. Finding the interval for which f of x is increasing will mean where is the gradient greater than 0. My gradient function is f dash x, and I require that to be greater than 0. This is why we've just plotted it on our calculator. I would like to know where does that line, that blue line, cross the y-axis and go from negative to positive. Now, by scooting around on the calculator, I can see it's going to be around 4, but I don't know exactly where that is. So I'm going to use second and calc and calculate for the 0 value. My left bound, let's quickly write that down. Find the cursor, left, the left side of my 0, the right side of my 0, x must be greater than 4. Because on my lovely graph, this thing crosses the x-axis when x is 4. Therefore, it is positive when x is greater than 4. Job done. You can also do this with algebra. If you are a person that would rather just use the calculator, as you should, rather than using algebra, skip this bit. We're going to solve for this being greater than 0. So we get a quarter x is greater than 16x to the minus 2. That is the same as 16 divided by x squared. That means that I get x cubed is greater than 64, so x is greater than 4. Same answer, but a lot more steps. Question 2. I really like these questions, and I feel like people panic on this and they go, oh my goodness, this is outside of the procedure that I already know, because it doesn't have numbers, and all of the practice that I've done is where I do have the numbers. What I say to that is, don't panic about not having numbers. Do what you would normally do and don't worry about the letters. Because even if I can't figure out the whole thing, just by following the procedure to find the normal gradient using this function, I'm going to get a lot of marks just by doing that bit. To find that normal, I would take my function, differentiate it to find the tangent gradient. Now, to find the tangent gradient, I would take some value of x, and that will give me the tangent gradient. So I have an x value in this coordinate. X is 2 and y is 4. But I don't need that y value right now, because all I need to use is x is 2. So dy by dx is equal to 2a multiplied by 2 add b, which is then 4a add b is, let's call it m, tangent gradient m. We remember, or we know, that the normal gradient is negative 1 over the tangent gradient. But my question has told me that my normal gradient is negative 1 over 3. So using that, I don't have to do much to realise, well, that means that m must be 3. My tangent gradient must be 3. Job done. I have not done. I have one equation now. This bit, we've already got about 3 or 4 marks. Well done. If you don't know how to go any further, we start to have a look at what numbers have we not used. So we have used this gradient and we have used this x value, but what we definitely haven't used is this y value. Now, I'm not saying that we won't use numbers again, or that we have to use all the numbers, but it's a very good starting place in problem solving. What have I not used, and what could I use it for? So I haven't used this y, but I have used this x. But I can use this coordinate in my original function. This is a function that connects x and y together, and I have an x and y value, even if I don't know what a and b are yet. So that means that 4, my y value, must be equal to a, 2 squared, plus b times 2, take away 10. So 14 must be equal to 4a plus 2b. This gives me 2 equations that I'm going to rewrite over here. 4a plus b is equal to 3, and 4a add 2b is equal to 14. Now, I'm going to use my calculator to solve this, because I think it's good for you to learn to use your calculator. I'm going to press apps, polynomial solver, I don't know what the SMLT stands for, simultaneous equations, and I'm going to type in 4. I'm going to say that a is x and b is y. You can see that I've typed this in already. I hit solve. X is negative 2 and y is 11. So that means that a is negative 2 and b is positive 11. Cool. I'm going to put that into my final equation. Not because I have to, but because I don't think it looks right without it. I don't have to, but it's there. Now, if I have extra time, by that I mean maybe I have 10 minutes at the end of the exam that I'm finished and I don't have anything to do, this is one of the ways that we are going to double check. Anything like this is so good for double checking because I can plot the function that I figured out, negative 2x squared at 11x, take away 10, and I can check the numbers that I should have on there. So I should have that when x is 2, y is equal to 4. We're going to use trace to find x is 2, y is equal to 4. Cool. That bit is correct. I'm happy. I can also find dy by dx on this, and I should get that dy by dx is equal to 3. So I go second, calc, dy by dx, where x is 2. dy by dx is equal to 3. So that makes me more confident that I'm probably right with this. Okay. Sketching question. Lovely. More calculator use. We're going to do this straight away. We're just going to copy this straight into our calculators. We've been given a function to sketch and a domain and a range in which to sketch it. There we go. So we've got, consider the function 27 over x squared minus 16x. Sketch the graph of y is equal to f of x for negative 4, 3, negative 50 to 100. Now, they expect you to use this domain and range within the window. The domain is the x values between negative 4 and 3. And the range is the y values between negative 50 and 100. And I've got a feeling that I've probably used the wrong kind of negative somewhere. Ah, there we go, because I tried to put it into the x scale. X scale should be 1. So y minimum of 50 and y maximum of 100. There we go. So we're going to sketch that. Go. I wish I had something in real life that would magically create lines like that for me. So this one goes like that, and this one goes like that. 4 marks. Easiest 4 marks you can get in an exam, that, because it's just copying out from your calculator. Use your graphic display calculator to find the 0 of f of x. Second, calc, 0. The 0 is where y is equal to 0. So it must be this point here, y is 0. I'm going to use the 0, again, so second, calc, 0. Mark the left side, mark the right side, and it tells me that my 0 is 1.19. So this point here is 1.19. Cool. Use your graphic display calculator to find the coordinates of the local minimum. Easy. Second, calc, minimum. Now you need to use your eyes to see the local minimum is here. Right around here. Don't know exactly where, but it's somewhere around here. So I'm going to put a value on the left side of it and a value on the right side of it and ask it to solve it. There we go. My minimum is where x is negative 1.5. and y is 36. Done. Min at that using calc. Although I almost don't need to write that bit because I've been asked to use the calculator. Use the graphic display calculator to find the tangent line. Super. This is a little bit different. Because I'm adding a tangent line instead of finding out some property of my line, I'm going to use second and draw to draw the tangent. I would like to give it the value x is negative 2. To do that, you just press the buttons and it will appear. Trust it. So there we go. Y is equal to negative 9.25, add 20.25. Done. If you want to round both to 3 significant figures, absolutely you can. There we go. Right, a nice finance question. Now, because it's a finance question, and I can see that as soon as I see money appearing, I can bet that I'm going to be using the TMV or TVM solver. So I'm just going to start by writing in this bit so I can start to fill it in as I read my question. I don't go through the letters one by one. I go through the question and see what I can fill in from there. So on January 1st of January 2022, Mina deposited $1,000. So therefore my present value is negative 1,000. I've given away $1,000 to the bank, or Mina has. I have an interest rate of 4%, compounded monthly. So monthly compounds is 12. At the end of January and at the end of every month, she deposits $100. So there must be negative 100 here because she's giving away that money and adding it to what's already in the account. It's a bit of a weird logic to wrap your head around. If you don't get it, come find me and I'm happy to sit down and try and go through that one with you. Future value, I have blank. Number of compounds, I also have blank. Calculate the amount that she has at the start of 2024. Well, I know that there's 24 months between 2022 and 2024, so my number of compounds is 24. Using all of this, I can figure out my future value by just using my calculator. So, apps, finance, TVM solver. You can tell that I've done this already today. So, I'm not going to bother resetting all these to 0. You can already see it. My future value should be 0, and my number of compounds should be 24. Everything else is the same as is in the question. So using this, I can now solve for my future value, which is 3,577. Solved for. I like to put an arrow here so the examiner knows what part of this did I do the solving for and what bit did I just write down from the question. Part B, how many complete months, there's a key word in there, complete months, counted from the 1st of January 2022, will Mina have more than 5,000? Cool, nice and simple. We make that 5,000. We work out the number of compounds, 36.46. Now, we really should write out the same thing again, but I am using a computer, so I will absolutely cheat and make things quicker here by copying and pasting and just changing the numbers that I need to change. So number of compounds is now unknown, but my final value should be 5,000. I calculate it, I get 36.47, which means that my complete months will be 37. Okay, question 5. This one is an interesting question. It's a reasoning question. It is not a question that you should rush into. Actually, you should never rush into any question. Think smarter, not harder. So, if I would like to find the inverse, or the value of the inverse when x is 1, or when something is 1, there are 2 ways that I could do this. Sure, I could find the inverse of x and then make x 1 and see what I get. Or I could think a little bit deeper about what happens between the domain and the range of different values. And that f of x, or h of x, will take numbers from the domain to the range. And the inverse will go the other way. So if I'm taking 1, putting it into the inverse, what comes out is a domain value, the original x value. But that means that if I put x into h, into this function, that will be equal to 1 because of the logic and how functions and inverse functions work. I can solve that much more nicely and easily than doing something else. So 2 over the square root of minus 1, which is h of x, add a half, is equal to 1. This tells me that 2 over square root of that is equal to a half. Therefore, 4 is equal to the square root of x minus 1. Therefore, 16 is equal to x minus 1. X must be 17. So h minus 1 of 1 will give me 17. I can check this on my calculator to just double check and see how things are. So if I plot this function 2 over the square root of x minus 1, add a half, and I plot that. I realize that my window is a bit weird, so I'm going to reset the window with the standard zoom 6. There we go. I can trace for the x value of 17, which is telling me invalid, and which should be giving me 1. So let's zoom out a little bit more, shall we? So trace, x is 17, y is 1. There we go. Super. If you wanted to do this the algebraic way, you would very quickly discover that this is not a question for 2 marks. Just a reminder, this is only worth 2 marks. We can start to do it the long way, let's call it. So if I've got h of x is equal to 2 over the square root of x minus 1 add half is equal to y, then to find my inverse, I swap those two around. So 2 over the square root of y minus 1 add a half is equal to x. And this will rapidly become very nasty. So that's going to be root of y minus 1 is equal to x minus a half over 2. No, it won't. That'll be 2 over x minus a half. That means that y is equal to 2x minus a half squared add 1. Done, kind of. So this is then the inverse function x. By the way, you do not have to do this. This whole section is only for the people that want to use algebra. Anyone that's happy to just use the calculator, how I've previously shown, please do that instead. It's way easier. H minus 1 of 1 will be, using my calculator, 2 over 1, take away a half, squared. Oh, I've got my squares in the wrong place. Squared, add 1, gives me 17. Same number, way more effort. Is it worth it? No. Okay, Find the domain of h minus 1. Well, the domain of the inverse is the range of the normal function. So this drawing that I did earlier, this is relative to the regular h of x. So our range of the normal function is all the y values. So if we have a look at my y values, yep, we've still got the original graphed on, and I have a look, is there a number that this never goes past? Yes, there is. If I trace along this and I go all the way over that way, I can see that y keeps on getting smaller and smaller and smaller, but I can already see it's not going to go past 0. So the domain of h minus 1 of x is greater than 0. Because the range of h of x is h of x, the y values, must be bigger than 0. So then when I flip it around, the domain of h minus 1 is the range of h of x. If that's not making sense, please come find me in school. If you are listening as a person who doesn't go to our school, why? Hi, but also why? Anyway, here we go. BC, I would like to find this length here. Might be worth loading into our common sense what I'm expecting here. I'm expecting this to be smaller than 25 because 25 is clearly the longest side. Just have a look, it makes sense, that's the longest one. So I'm expecting a value that's smaller than 25. Cool. Let's do this. So to find BC, I've got a side, and an angle, so I shall use the cosine rule. A squared is b squared plus c squared minus 2bc cos a. So in this case, bc squared is going to be equal to 25 squared, add 15 squared, minus 2 times 25 times 15, multiplied by cos 22. We put that into our calculator. And we get 25 squared, add 15 squared, take away 2 times 25 times by 15 times by cos 22. Okay, and I square root my answer. 12.43. That's the final value, not the squared of it. Now, does that make sense to us? Yes. Yes, that makes sense. I'm very paranoid with these kinds of questions, so I will almost always take that number and store it as a letter, just in case I have to use it later. You should never round values mid-question, or use rounded values in a later question, because the accuracy will mess up things. Okay, so next bit. Given that ABC is acute, calculate the angle ABC. So by doing that, they are referring, let's take that and shift it that way just a little bit, make this a little bit tidier. We are looking for this angle right here. And we can do that using the value that we've just found and using this 15. I'll be honest, I don't like doing that because that means using a number that I've worked out, so I could be wrong. The examiner should not mark me down for using the incorrect number in a correct way, but not all examiners are perfect. So this is a risky move, using a value that I've calculated in a later question. We're going to do it anyway. And then I'm going to show you what I think is a better way. So we're going to use the sine rule of sine 22 over BC, so 12.43 is equal to sine theta over 15, which means that 15 times by sine 22 over 12.43 is equal to sine theta, which means that theta will be the negative inverse, the sine inverse of 15 sine 22 over A, because I'm not going to use the rounded value, 26.87. Done. Now, I don't like doing that because it's using a value that I've worked out, and that doesn't sit right with me. Because when it comes to maths exams, I'm paranoid. I don't want to lose a single mark. So instead, this is going to be my little diagram for what I'm going to do. Whoops. Let's see if I can make a nice looking triangle. There we go. Instead of figuring out theta, as I've named it already, let's figure out this one, y, because I can work out y without using... Oh no, I still have to use that one. That's fine. Never mind. Yeah, okay. Annoyingly, they've constructed this quite well, and I have to use that value. That's quite annoying. I'm sure there's a way that I could do it without, but not without some further shenanigans and messing around with things unnecessarily. Cool. Okay. Moving straight on. Finding... Ooh. So, Ron sails his boat from point R with a distance of 150 kilometers on a bearing of 120 degrees to a point blah 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 where he sails on 38 degrees to point T, and down here it's telling us the point T is directly east of point R. So I'm going to draw in a line connecting R and T. And they're asking me to find the angle RST. So they would like, or the exam would like me to find this whole angle here. Now to find that whole angle, I'm first going to need to figure out this small bit that I shall call theta. That's not too bad to work out. If we use a bit of simple geometry and I draw in a line there to make this a 90-degree or a right angle triangle, I can see that's a right angle, which means that bit must be 30 degrees. If that bit's 90 degrees, 90 add 30 is 120. And then 120 add theta must be 180. So theta must be 60. Which means that the angle RST must be 98 because I add on the 36. 60 add 38 is 98. Cool. Calculate the distance that Ron sails to 1 minute. Quick gut check. Does that make sense? Does that make sense for this to be 98 degrees? Yes, it does. It fits with our common sense. So that's okay. I'm sure you could probably do this with a sine rule. Or even, actually, you could do this just with some sort of trigonometry. But honestly, using the very, very basic stuff is much happier and easier. So I'm not even going to show any other way of doing it. Just stick with the basics. Okay, calculate the distance that run cells to return directly from point T to point R. So we would like to find what is this distance from T to R. Have a quick think about that. Yeah, that's going to be using the sine rule quite nicely. So, to use the sine rule, we need two angles and two sides. Sine rule, I remind, is A over sine A equals B over sine B is C over sine C. Now, I have, this side, 150, but I don't have the angle opposite. I have this angle, this 98 degrees, but I don't have the angle opposite. I'm just going to redraw it over here because my diagram is getting quite messy. So that's 98 degrees. This is R, T, and S. And I know that that's 30 degrees. And I want to know the length of that side. So I have that length. I don't have the opposite angle. I have that angle. I don't have the opposite side. But again, using super basic maths, I can just work out what that angle RTS will have to be. Pop these things into the sorry, I'm writing this behind the calculator. There you go. 180. Take away 98. Take away 30. Gives me 52. So that angle there must be 52. Okay. Again, using my calculator and using the sine rule, I can now do the rest of it. So 150 over sine 52 is equal to B, the unknown side, so let's call that RT, over sine 98. So 150 multiplied by sine 98 divided by sine 52. And we're going to type that into our calculator. 150 multiplied by sine 98 over sine 52. Okay, so I need to take that number and math, decimal, 188.5. Cool. Common sense check. Does that feel right? Yes. That feels right for that length right there to be 188 meters, kilometers. I should probably answer the question, well, what would we do if it didn't feel right? Or when might this not feel right? I will show you when this might not feel right. And this is if my calculator, by mistake, is in radians. Because if I do this in radians, I get a negative length, so it's definitely wrong. By the way, this also goes for the questions that we were doing before that I noticed quite often. Is that now too far up? Oh, it's just repeating. That's cool. Much further up, this one. I noticed that some people got this wrong in the exam because they had their calculator in radians and not degrees. It's really important that you do that gut check. And what if that is the wrong thing? What if? Because it does happen, and that's okay. Right. last one, or next to the last one anyway. Find an expression, or sorry, find the gradient of the water slide when x is equal to 2, and I've been given this function h dash. Now we know that this dash means that this has been differentiated, and if it has been differentiated, that means that this is the gradient function. And the gradient function tells me, well, what is the gradient for a given value of x? So all I need to do is put 2 into my function, and that will tell me what my gradient is. So 0.6 multiplied by 2 squared, take away 1.8 multiplied by 2, get rid of that extra bit, and I get negative 1.2. Gut check, common sense check. Where could I visibly see some property, some part of this negative 1.2? Well, I could see it on my graph. Where x is 2, I have a gradient that is going down. So I have a negative gradient. This is negative. I now have more confidence that I'm probably correct. At the exit point, the water slide, x is equal to 4, and h is equal to 1.4. Find an expression for h of x. Now, I intended this to be a reasoning question. Keep in mind that at the time of this midterm, we hadn't yet covered integration. This question is super easy once we know integration, but I deliberately put it here as one of the last few questions, deliberately to be a reasoning, problem-solving type question, to see if you could reason backwards. So I know that this is the gradient function, and I know how differentiation works. I know that I get n x n minus 1. So that means that reasonably this would be x cubed and this would be x squared. But that means that whatever I have here, this, call it box, multiplied by 3 gives me 0.6, so this must have been 0.2. Using the same logic here, something multiplied by 2 must have given me negative 1.8. So this must be negative 0.9. I could have had something here, a constant, that will bring me to a constant here, some number that I don't know. Now, I can find the value of that number using the points that were given to me. H of 4, 0.2 to the power of 4 cubed, minus 0.9, 4 squared, add c, is equal to 1.4. If I do that on my calculator, I get negative 1.6. Sorry, I realise I'm hiding this behind my calculator. Negative 1.6 add c is equal to 1.4. If I now do that on my calculator, just to show you, multiplied by 4 cubed, take away 0.9 of 4 squared, gives me negative 1.6, so therefore c must be 3, so h of x is equal to 0.2 x cubed, take away 0.9 x squared, add 3. 0.2 x cubed, take away 0.9 x squared, add 3. Now at this point, I think it's really important that we remember how to double check things like this, and we can double check things like this. I can put the function that we've just found into my calculator. Take away 0.9 x squared, add 3. Graph, boom. Now, if I have a window of between 0 and 4, let's give it an x window of between 0 and 4. In fact, let's make it go to 5 and start at -1, because I always think giving yourself a little bit of a gap helps the brain to understand. So I'm going to give that -1 and 5, and we'll just see what comes out. There we go. That looks almost the same. So I'm now happy that this is probably right. And in fact, I can trace it to just get a sense of where these numbers are. Good. It makes sense. Okay. Write down an integral that can be used to find the area of the shaded region. We didn't do this because we at this time had not done integration. So I just gave you the answer for this part. Now that we have done integration, I can't miss the opportunity just to show you how to do this bit, that we integrate. And now in lessons, we know that integrating xn is 1 over n plus 1 x n plus 1, add c. So using that same logic, we have 0.2 x to the 4 over 4 minus 0.9 x cubed over 3, add 3x, add c. And this would help me find, this would be that integral. So 0.05 x to the 4, take away 0.3 x cubed, add 3x, add c. Find the cross-sectional area. Well, I would integrate this function, 0.2 x cubed minus 0.9 x squared, add 3 dx, between 0 and 4, because my slide is between 0 and 4. Again, this wasn't in your exam. The only reason I am doing this is just because I think it's really good for you to practice where these things come from. So I can use math, function integrate, which is this number 9 here, 0, 4, and now all I need to do is just copy out the function that I've got. X cubed, take away, whoops, 0.9, x squared, add 3. There we go. And I'm integrating with respect to x. 5.6. On with what I actually asked you to do. I gave you the answer in the exam. The area is 5.6. So if I now know that the depth is 1.2, to find the volume, I take the cross-sectional area, 5.6, and I multiply it by 1.2. So 5.6 multiplied by 1.2 gives me 6.72. Done. Write down 3 equations in terms of A, B, and C using the conditions given. So they've redone the construction, they've changed the design, and I've been given 3 things, 3 pieces of information to create 3 equations. Cool. I've also been given the general form. This is another one of those questions which it's just like, don't panic. Do what you would normally do. The first one's nice and easy. So h of 4 means put 4 in. So a of 4 squared plus b of 4 add c is equal to 1. So 16a plus 4b add c is equal to 1. Cool. Now the other two, maybe we don't know how to do that, but we do know how to differentiate, which is what this h dash means. So the differential would be 2ax plus b, and now I can just put my numbers in. So h dash of 2 would be 2a times 2 add b. So 4a add b is equal to negative 1.2. Same with h dash of 3. H dash of 3 would be 2a times by 3 add b is 0. So 6a add b gives me 0 again. Ta-da! I now have 3 equations. And I can use these 3 equations to work out all the bits that I need to know. I can do this using my calculator and specifically the simultaneous equation solver that we looked at earlier. The difference is I have now 3 equations and 3 unknowns, and again I'm going to say that A is X, B is Y, and C is Z. I'm now imagining that every American in my class will say, no sir, that's Z, but I'm going to shut up. Right, so we've got 16A, add 4B, add 1C is equal to 1. We've got 4A, add 1B, add 0C is negative 1.2. And the other one, 6A, add 1B, add 0C is equal to 0. Solve. Job done. So we've got X is 3 over 5. Y, which is A by the way. B is negative 18 out of 5. And C is 29 over 5. Cool. Again, this gives us an equation that we can use. At minus 18 over 5x, add 29 out of 5. If I have extra time, and I'm looking at this and I'm feeling those numbers are weird, I don't like those numbers, it feels like those numbers have come out of nowhere, plot it. So quit. We're going to plot, and this time we're plotting 3 over 5x squared. Take away 18 over 5 x, add 29 over 5. Graph. It's got the right shape. We're going to zoom out just a little bit. It's definitely got the right shape. I'm going to trace and find out what happens when x is 4. Y is 1, as expected. Good. I'm going to calc dy by dx, and I would like to know what happens when x is 2. Negative 1.2. Good. And what is the gradient, dy by dx, when x is 3? Perfect. Everything's as it should be. I'm confident that I'm correct, even though the numbers I've got are super, super weird. Done. Oh, that's part F as well. Whoops. Explain why Andrew's claim is correct at the point where x is equal to 2. And claims that it will provide a smooth pass for a person using the slide. And the point where x is equal to 2. Okay. Well, where x is equal to 2, we've done this before. It's the same gradient as before. When x is 2, x is 2. Therefore, the updated design will provide a smooth path because the gradients will be the same. So keep in mind that this new function is between 2 and 4. which means that the new bit only starts from here. New bit. In this new bit, so long as this bit's got the same gradient, there won't be a bump when you go over that bit of the slide. So this bit is quite as simple as it's the same gradient. Now, I do think these questions, or these parts of the questions, are super difficult because they require you really, really carefully thinking about the context and just what the hell is happening. Cool. Because gradient is the same. Gradient is the same. I'm going to write that better because not much better. Okay, last one. Whoa. Doing good for time. The population of the bacteria P can be modeled by the function blah 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 blah, where T is the number of hours since the experiment began. Write down the value of P of 0. Nice and easy. P of 0 is 1200 multiplied by K to the power of 0. K to the power of 0 is 1, so therefore that's 1200 times by 1, which is 1200. Nice and simple. Interpret what this value means. Well, it's the starting value. This is the initial population. Starting value, initial population if you want to be fancy. It's the amount of bacteria at the start. Any variation on those words will work. 3 hours after beginning the experiment, so when T is 3, just check T is in hours. Yes, it is. T is number of hours. The population of the bacteria is this. Find K. Cool. This is a nice logs question. Times by K to the power of 3. Oh, it's not a logs question. 18750. So K cubed is equal to, I'm going to use my little old calculator for this one. Make that a little bit bigger. 18750 divided by 1200. 15.625. Which means that K must be the cube root of the answer, which is 2.5. Oh, what a nice number to appear. Sorry, that's one of those numbers that's like comes out so perfectly, it just gives you that really happy, warm maths feeling. Anyway, I'm a normal human being. Anyway, if anyone's watching at this point, I am shocked and amazed and genuinely quite impressed. If anyone is still watching this video at this point, honestly, come to me in school and say the words "you're a normal human being," and then reference this video, and I will give you chocolate or something. So I'm genuinely impressed if you're still watching an hour in. Well done. Anyway, find the population 1.5 hours after the thing started. So 1000 P 1.5 is equal to 1200 multiplied by 2.5 to the power of 1.5. There's a lot of 0.5s in that. Multiplied by 2.5, power of 1.5. 4743. Cool. Here we go. So, conducts a different experiment with a different species. I've got a new lovely formula. Find the value of T when the two populations are equal. Okay, now there's lots and lots of ways that you can do this, and by lots and lots of ways I mean 2. That wants to be equal to that times 2.5 to the power of T. And now it's my job to figure out what is T. It's only 2 marks, so they are not expecting lots of algebra. They're not expecting lots of craziness. They are just expecting you to get the calculator, plot it in the calculator, both of them. So 5,000 multiplied by 1.65 to the power of x. And I do the next one. 1,200 times 2.5 to the power of the same value x. And I graph it, and I see absolutely nothing. Probably because I need to zoom out a hell of a long way before I start to see anything. This is where being a maths teacher kind of helps, because I can kind of see where these things are going. That I'm going to get very, very, very high y values. So, there we go. I can predict that I'm going to need to change the window in this way. But you can still see, like, it's also a lot of trial and error, because the first time I did that, I didn't get it right, and it's still not correct. So I'm going to keep on making this window, the x range or the x domain smaller, and the y range larger. In fact, let's just go straight to 40,000, see if that's enough at this point. Graph. There we go. And we've got a nice intersection. So now I can ask for the calc. Intersect. Yes on the first curve, yes on the second curve. I don't want to guess, please. That's my intersection. X is 3.43. Yay. Yes, you can also do this with logs. Let's do it with logs, because I know that there's going to be two people I can think of that will immediately ask me, but sir, how do I do this without my calculator? And my answer for you is, you still need your calculator, because you just can't do this, sadly, without your calculator. Because even if you're using logs, you're going to use your calculator. So 1.65 to the power of t. I know that I've only just done that one, but I still can't do that one in my head. 5,000 over 1,200. Okay, so 25 over 6, we'll go with 25 over 6 is equal to, I'm skimming over this because this bit is intended to be seen by people that are happy with algebraic manipulation. If you are not happy with the things that I am doing, just do it with the calculator in the way that I've shown you already. Yeah, so that hasn't given me a nice number, so I'm going to leave it how it is. So I'm going to go log base 2.5 over 1.65 of 25 over 6 will give me t. So let's do that. Log base, this is about the weirdest log base I've ever done for quite a while. 1.65 of 25 over 6 equals 3.43. There you go. Same answer, but that's more than 2 marks worth of working out, right? That took longer than it should have done for those 2 minutes. Mark per minute. Okay. It takes 2 hours and m minutes for the number of bacteria in the second experiment to reach 19,000. Find the value of m. Okay. Nice and simple. I'm going to start by just making them equal to each other. Multiply 1.65t is equal to 19,000, which means 1.65t is equal to 19,000 divided by 5,000, 19 over 5, which means that t is going to be log 1.65, 19 over 5. Log, that's the button, 1.65 of 19 out of 5. 2.665. 8. So now what the question is asking me is what's that bit in minutes? Which, I mean, we can do that. Now, if you have a Casio calculator, I can press this button, this one right here, and it just tells me that that's 2 hours, 39 minutes, and 57 seconds. If you're on this calculator, I don't think it has that button, I'll be honest. Okay, let's just do the calculation properly. So math, find log base, there we go, 1.65 with 19 out of 5, there we go. I'm just going to have a quick read through just to see if there is anything that looks like it could do the job. I think there is, to be honest. No. Unlucky TI users. Unlucky. So instead, we're going to take my answer. We're going to take away 2. There we go. And then we're going to multiply our answer by 60, being 60 minutes. So there we go. So I now know that that bit must be 39 minutes. Not much extra work, but there you go. Okay. Actually, let's just show how we got to that bit. 0.6658 multiplied by 60. Okay, last bit. The bacteria, it's growing in a container, the volume, the available volume, determine how long it would take to fill the container. Oh, each bacterium in the second container. This is where you've got to read the question carefully. So each bacterium takes up that much space. The amount of volume is that. So if I do a very quick that one divided by that one, I know how many bacterium can fit in. Grab the old faithful calculator and 2.1 times 10 to the minus 5 over 1 times 10 to the negative 18 gives me 2.1 times 10 to the 13. Does that make sense to me? Yes, it does. Because I've got an incredibly small thing, bacteria, trying to take up an entire jar. So yes, it's going to be a very large number. This makes sense to me. Cool. Once I've got that bit and I know that I'm using the second experiment, I just want to work out what time is. So 5,000 multiplied by 1.65 to the power of t is equal to 2.1 times 10 to the 13. I now want to work this out. Use your calculators. I'm going to do this in 2 ways, both using calculators. My gut instinct would just be to log it. 1.65 to the power of t is 2.1. In fact, let's just do this on the calculator. So 2.1 times 10 to the 13, divided by 5,000 gives me 4.2 times 10 to the 9. So log base 1.65 of 4.2 times 10 to the 9 gives me a very large amount of time. Log 1.65, 4.2 times 10 to the 9, 44 hours. Does that make sense to me? Yes, it does. The other way of doing it is using this calculator. I just deleted the function that I wanted to use, 1.65 to the power of x. Clear that one. Graph, there we go. And I would like to solve calc for a particular value. There we go. No, I would like to do it the other way around. I want it to be equal to this incredibly large number, which I won't be able to see. Okay. Fine. I bet there's still a way of doing it. Instead, you can just write it into here. 2.1 times 10 to the power of 13. Very, very, very large number. Graph. Now, this is where I'm going to have to zoom out a lot. In fact, no, I'm going to leave that as it was, assuming. I know that I need to change that because I've already done it. But if you're doing this, you know that you can't see it, so you're just going to make this a really big number. And then when you graph it, you still can't see it. So you're going to zoom out more. And I know that I'm going to need to put a lot of zeros on this before I see it. There we go. Ah, look, see, the red and the thing's there, but I can't see it because they don't overlap where I can see them. I'm going to change that to a 13. And I'm going to change that to a 50. There we go. I have an intersection. So 2, calc, intersect. There we go. 44.248. 44 hours. Done. I really hope all of this has made sense to you. My goodness, if you have watched this entire hour-long video, wow, genuinely very, very impressed. Thank you. If you have questions, please ask me. I can't think of anything else to say. Have a lovely day. Bye.